Hey guys, today we're going to look at graphing rational functions, and this will be on slide 1255. When we graph rational functions, as you can see from this graph here, we have, they mimic the graphs of reciprocal functions that we just got through going over. You'll still have a vertical asymptote and a horizontal asymptote. We'll get our vertical asymptote by looking to see what makes the denominator equal 0, but we're going to have a different procedure for finding horizontal asymptotes. You may still use Desmos or your graphing calculator to help you as a resource, but remember, you always have to have your asymptotes dashed in. If we look on slide 1255, there's some notes that show you the procedure for finding your horizontal asymptote. So if the degree, so our equation is going to be in the form of y equals some function of x over another function of x. So we're going to say a of x and b of x. So if the degree of a of x is less than the degree of b of x, then our horizontal asymptote is going to be y equals 0. If a of x's degree equals the degree of b of x, then the horizontal asymptote is going to be y equals leading coefficient of a of x over leading coefficient of b of x. And if the degree of a of x is greater than the degree of b of x, then there is no horizontal asymptote. Okay, let's look at our first example. And your first example is on slide 1256. So example 1 asks us to graph f of x equals x cubed x cubed over x minus 1. So to find our vertical asymptote, we take our denominator and we set it equal to 0 and solve, and x is equal to 1. That is my vertical asymptote, so I could go ahead and dash that in. For our horizontal asymptote, we're going to compare degrees. The degree of the numerator, which we refer to as a of x, is greater than the degree of the denominator, which we're going to call b of x. So that means that we have no horizontal. And in fact, it's more than 1 than it is. It's larger than the denominator by more than 1. So no horizontal asymptote. You could make a XY chart and plot points, but using Desmos would probably be the way that most of you do it. For example, if I substitute -1 in, I get 1/2. If I substitute 0 in, I get 0. If I substitute a positive 1/2 in, then I get a negative decimal value. And so my graph looks something like this, approaching the asymptote but never touching it. If I substitute in a 2, then I get 8. So I have a point way up here, and my graph looks something like that. But remember, you can get your shape from Desmos and just make sure that you have your asymptotes dashed in. And we only have one asymptote on this one, and it was a vertical asymptote. Okay, let's look at example 3. In example 3, they want me to graph f of x equals x squared plus 4x plus 4 over 2x minus 1. So the first thing I want to do is find my vertical asymptote. And I get my denominator equal to 0. I solve for x. So x equals 1/2 is my vertical. And then when I go to find my horizontal, the degree of the numerator is greater than the degree of the denominator by 1. Because I have a exponent of 2 here, understood to have an exponent of 1 here. And when that happens, we have no horizontal, but we have what's called an oblique asymptote or a slant asymptote. And to find that, we do long division. So we've done long division before. We take 2x minus 1 and divide it into x squared plus 4x plus 4. So how many times does 2x go into x squared? It goes in there half x times. And when I multiply, I get x squared minus half x. I draw my line, change my signs, and I get 9/2 x plus 4. How many times does 2x go into 9/2 x? 9/4 times. It's just 9/2 divided by 2. And then this is my answer. As soon as I get y equals mx plus b form, then I am finished with finding my oblique asymptote. So I have two asymptotes, y equals 1/2 x plus 9/4 and x equals 1/2. So let's do the graph for that. So x equals 1/2, I will dash that around here. And then for the y equals 1/2 x plus 9/4. So 9/4 is a little over 2. I'll begin with that. And then I'll move my slope. So I go up 1 and over 2. And I have that dashed. And then I can use Desmos to see that I'll have one curve in this section and one curve down here in this section. So as long as you have your asymptotes dashed in, you can just use Desmos to see where your curves. Or I could put a point in. I could put this point 1 in, see what the y value is, and know that my graph would lie up here. Okay, we got one other type of graph when we're graphing rational functions, and that would be looking at example 4. So in example 4, they asked me about a point of discontinuity. So sometimes when we have our rational functions, they are not in simplest form. For example, on this one, if I just headstrong go into this trying to solve it, then I would say that my vertical asymptote is x equals 4 because of that denominator. But remember, x squared minus 16 factors into x minus 4 and x plus 4. So the factors of x minus 4 cancel. So 4 is still a restriction in my domain. If I was stating my domain, all the x's such that x cannot equal 4, but it is not an asymptote since it canceled out. So since these factors canceled each other, I don't have an asymptote, and I just have this line. But because x equals 4 is not part of the domain, when I graph the line, so my y-intercept of 4, my slope of up 1 over 1, at 4, 8, I have a hole in my graph. So I would have a line, but this value 4, 8, I have a point of discontinuity. And that does not show up on Desmos, nor does it show up on your graphing calculators. So that's something else that you have to figure out with your algebra. Okay, let's see if we can review these examples real quick and see what we need to do when we're graphing rational functions. So if I look back at our notes, in this example, in this first example, my denominator, x can equal 1, so that becomes my vertical asymptote. When I compare my degree, x cubed is greater than just x, so there's no horizontal, and then I dash in my x equal 1, and then I can use Desmos to help me with my shape. Then when we look at our slide where we are determining our horizontal asymptotes, when the numerator is less than the denominator, automatically y equals 0. When they're equal to each other, automatically leading coefficient over leading coefficient. And when it's greater is when you have an oblique asymptote. And when we have an oblique asymptote, we have to do long division. When we get it in the form of y equals mx plus b, then we have our slant asymptote or our oblique asymptote. And then example 4, we are looking for the hole in the graph, and that's this one. So my numerator is needs to be factored, and when I factor it, it cancels with something in my denominator, which then makes my function in simplest form just be the equation of a line. But because there was a restriction in the domain, we have a point of discontinuity. Let's look at one where we would have a horizontal asymptote where the numerator and the denominator are the same degree. So if I had x plus 1 over x plus 5, for example. For my vertical asymptote, I would take the x plus 5 and set it equal to 0, and see that x equals negative 5 is my vertical asymptote. Then when I compare the degree, this is x and this is x. So for my horizontal asymptote, the degree of the numerator is equal to the degree of the denominator. So then my equation is y equals leading coefficient over leading coefficient. Well, in this one, 1 over 1 will make my asymptote be y equal 1. So then when I go to graph, I had a vertical asymptote at negative 5 and a horizontal asymptote at 1. And then I could let Desmos help me and see which quadrants that my curve would belong to. Okay, so 3 things will happen when you're looking for a horizontal asymptote. Either it's going to be y equals 0 because the numerator is less than the denominator, or it's going to be y equals leading coefficient over leading coefficient because the degrees are equal, or you have no horizontal asymptote. You have an oblique asymptote when the degree in the denominator, when the degree in the numerator is greater than the degree in the denominator by 1. and you have to long divide. Okay, if you have any questions, you can email me. I'll have the assignment posted, but it's going to be slide 1263. We're going to do 2 through 18 even, 28, and 30. All right, email me with any questions.